Well, good evening and welcome to Space Oddities. If you're new here, an especially big welcome. With us today, we're a bit short on the ground today, as far as the panel goes, but stick with us. If anybody's here who was with me for Astronomy Ireland's Star Party on Saturday, you're particularly welcome. I hope you had a good time that night. I really enjoyed myself, and I got back to Spain safely, although I had a bit of an interrupted flight because there was a baby screaming for 2 hours behind me on the plane. So I'd had a 4 o'clock start this morning and I did want to sleep on the plane, but it wasn't to be. Never mind, these things happen. So you're all very welcome. Thanks for being here. And also thanks to those people who joined us earlier in the day for our coverage of the Artemis 1 launch, which was, as you probably know, sadly scrubbed because of an engine chill problem. But hopefully later in the week, NASA will try again, having rectified the problem. So we'll move straight on. And as custom dictates, we'll move straight on to Roger. So Roger, what's up?
Well, the usual stuff. So I'll just go through my regular routine.
Thank you.
No problem. And here we go. Okay, everyone. So here we go for this week, the 29th of August to the 4th of September, into another month. And so we start off with a thin moon right up through to the weekend coming with our first quarter of the moon, which is gradually appearing for us. While I was up in the night sky, the wee hours of this morning, I did a quick grab of Mars, and here we are. It was up quite high in the night sky, so I managed to get quite a reasonably clear shot. Unfortunately, with Jupiter still being quite low at the latitude that I currently am at about 51 degrees, it's still not too good with the seeing, and unfortunately resulted in a nil point from Jupiter.
Oh, what a shame.
But a few nights ago, it was a bit clearer, and I managed to quickly grab this, which was one of my better attempts. And as you can see, there's the moon Io fairly close to the planet itself. And the following night, which is something to what Andy was seeing over in Ireland, where Ganymede is almost completely occulted.
Yes.
And I managed to get that with my C11.
I thought you grabbed these out of the Cassini archive.
No. from my poor little backyard in Somerset in the UK.
So what? Tell the viewers what telescope you used for that.
That was a Celestron C11 with a 3 times Explore Scientific Barlow on it.
Right.
And yes, my only Explore Scientific product, which I managed to mention to Scott Roberts last week's visit. So yes. I think he was pleased on that little promotion.
He looked absolutely delighted, Roger.
Yeah. Well, somebody's got to say it anyway. So
yeah, absolutely.
There we go. So that was quite a clear night on those 2 nights. So pleased with that. Right. Okay. So the weekly roundup of the planets, which we've got Saturn now in the south, Jupiter at its reasonably higher latitude, and Mars now arriving up into the evening skies. And this is now from midnight. So things are starting to look a bit more promising, and also the winter constellations now appearing a bit more prominently. Mm-hmm. And as you can see, they're coming up to a better latitude there.
Don't you find, Roger, that all of us, it's such a depressing time of year when you start seeing the Pleiades coming over the horizon and you think, oh my God, winter's coming again. That's the summer over with.
Yes, winter is coming.
Because here in Spain, I've been seeing the Pleiades for a while now, and it just summer seems to get shorter every year.
On the other hand, if I get up early enough in January in the morning, I can see Scorpius. So you see a summer constellation in the middle of winter. It's just a matter of timing.
Yes, and of course I've got Scorpius very high in the sky here, and it's great. And because our southern horizon here is just beautiful, and it's just like jewels in the sky, Scorpius, in the evening. It's fantastic.
Yeah. Anyway,
Yeah.
should we have any listeners or viewers in the Southern Hemisphere, this is what you're expecting at 1 a.m. in the morning, an hour or so later in relative terms, where you're far more fortunate to have Jupiter and Saturn even higher in the night sky than we currently are experiencing. So even better visibility of all those details that we longingly wish to have up in the Northern Hemisphere. But there is a new image from James Webb, which is Messier 74, or the Phantom Galaxy, which is 95,000 light years away. And I shall just clear the text, and there is one of those swirly images like we had from last week. And
that's beautiful.
And there's another version in the different wavelength, which is that. Even more amazing.
That is amazing.
I don't know how they managed to get so much detail, but it's absolutely fascinating.
And you can see right at the center a bright dot.
Yeah.
Oh, right, yeah.
Yeah, it's like a rectangular hole down at the bottom there.
Yeah, it is. Yeah.
So
I am drawn to that sort of differential gravity-induced cavitation, for the want of better words. These holes that are like a soap bubble almost, sort of surface. It's rather interesting. The whole universe is a bit like that on a larger scale.
Yeah, full of holes.
Full of holes.
So that bright dot in the middle, the infrared radiation, must be associated with the supermassive black hole.
That little dot.
I would think, being right at the center. So that's where the supermassive black hole is. I assume that M74 is one of those galaxies with a supermassive black hole. It's not one of the weird ones without one.
No.
So that's where the black hole is.
Yeah, there's lovely
that's only been released in the last 24 hours or so. So I was fortunate to grab that quite quickly.
Is it a James Webb release, or was it an astrophotographer? Do you know, Rog?
I'm not aware of who produced the image from that.
Okay, because last week's was from an astrophotographer when she got the whole.
That's right.
Because the data is available for anybody who wants to have a go at producing these images.
Yeah, so, perhaps Kevin knows. Kevin, if you're there, perhaps you know if this was an amateur image or an official release. Tell us in the chat.
Okay.
If you know.
Right.
You know, Andy, when you were talking about the Pleiades rising and saying, "Oh no, winter's coming," I had the opposite reaction. I say, "All right, Halloween is coming." And, of course, 1,000 years ago or so, the ancient holiday of Samhain, which now became Halloween, was recognized when the Pleiades crossed the meridian at midnight.
So I didn't know that.
Yeah.
Oh, that's interesting.
It's the astronomy of Halloween, our cross-portal holiday.
Oh, okay.
Well, I'm actually in two minds about it, Lou, because on the one hand, as a human, I think, oh God, another year's gone, winter's coming again. But then I think, great, the winter constellations are coming. So there is that.
But it also means we've done another orbit of the sun.
Yeah, that's true. We've survived another one. Okay, thank you very much, Roger.
Thank you.
Michael, tell us a bit more about what happened today with Artemis then.
Yeah. Right. I've got a short video which I'd like to show in a minute. But as you all probably know, Artemis 1 was scrubbed due to a problem with the plumbing in the engine number 3. And what I have to show you now, this is an interview by the Public Affairs Officer at NASA with the NASA Administrator Bill Nelson. He has some interesting comments to say. So I'll just play this to tell you all about it. Just bear with me a second. And if I share my screen, I'll be with you in a sec. Okay, share screen. So that one. Okay, so here we go.
And don't forget to share your sound as well.
Florida. I am here with Administrator Bill Nelson, who was on hand for the launch today, which
You hear that,
I
okay?
hoped to be
Yeah.
a big moment in history for the Space Center, but instead it'll have to wait for another day. The launch attempt was scrubbed. Administrator, thank you for being here. What are your thoughts? How are you feeling after all of this anticipation and build-up, and then unfortunately couldn't go today?
We don't launch until it's right. And in fact, they've got a problem with the gases going on the engine bleed on one engine. You can't go. There are certain guidelines. And I think it's just illustrative that this is a very complicated machine.
Ooh, we lost it.
Have to work. And you don't want to light the candle until it's ready to go. I have some personal experience in the crew that I participated in on the 24th flight of the space shuttle. We scrubbed 4 times on the pad.
Okay.
And the 5th try was a flawless mission. We know, had we launched on any one of those scrubs, it wouldn't have been a good day. And so that was Hoot Gibson and Charlie Bolden's crew. And so, this is just part of the space business. And it's part of particularly a test flight. We are stressing and testing this rocket and the spacecraft in a way that you would never do it with the human crew on board. That's the purpose of a test flight.
And you talk about the complexity, and certainly that is the case here, and learning as we make these attempts. In fact, this engine bleed was something that they wanted to see in wet dress rehearsal number 4, didn't get an opportunity for it. So for the hardworking team that is still here actually gathering data from this rocket and its current configuration, any message for the launch team?
I want them to know that they're doing the perfect job that they always do. They're taking an opportunity while that vehicle is still fueled up to work this problem, and they're going to work it. They'll get to the bottom of it. They'll get it fixed, and then we'll fly.
And when we fly, we hope to have all of our guests back. Of course, there were big crowds here for this attempt. A lot of special guests, including Vice President of the United States, Kamala Harris, was here. Did you keep them briefed on what was happening and what happens next?
Yes. She and I had a good visit. I met her at the airplane. I came straight here to talk to some of the launch control folks, and she is fully briefed on the whole thing. She's very happy to be here. She is an enthusiastic space booster. As is President Biden. So this whole thing will make our country proud.
And Kamala Harris also chairs the National Space Council, so has a big role in our space program here. Senator Nelson, Administrator Nelson, thank you for your time. Appreciate you being here.
Thanks.
And giving our leadership here to this launch effort. We'll have to wait for another day. The next availability is September 2nd, though we don't know at this point if the launch team is going to use that. So we'll wait for a press conference roughly 4 hours from now to find out more about it. That's it for now for NASA TV and the Artemis 1 launch attempt coverage. I'm Daryl Nail signing off. Have a good day.
Okay.
Thanks. Yep. So there you are. So Bill Nelson saying, what you'd expect him to, really.
Yeah, I just thought there was some good words there really from him, really.
Yeah, absolutely.
And praising the launch teams and everybody involved. It's good. Oh, Daz, you're muted.
As we were saying during the day, this was a test flight. This is to test every single system. They had problems with the wet rehearsals, which they took back and they resolved. And these things happen. Unfortunately, I mean, there was a problem with refueling in the night, in the early hours of this morning for me. And there was talk of even possibly there could have been a scrub. But they continued, they worked around the system, they got it working again, carried on refueling. And then later on, they even started to refuel the upper stages earlier than they normally would to try and regain some time. But this, unfortunately, it was engine number 3 on the bleed system. And the idea of the bleed system is it's supposed to cool the engine down, because you don't want to suddenly infuse it with a lot of really freezing cold liquids, which could cause damage itself. I mean, these things are so cold. And one of the interesting facts that I heard today is on the main core, the hydrogen tank, the hydrogen is so cold that the tank actually shrinks 8 inches in diameter.
Great.
So yeah, it's a massive amount. I was surprised when I heard it. So it's not surprising you get these things with their flexing and their buckling and all this contraction, and the likes. There was also they thought they had a fracture in the core stage, in some piping and some plumbing, but as it turned out, it was just they put on some spray insulation to protect the piping, and it's quite a thick piece of insulation, but apparently it cracked. And what was happening is that due to the cold air, the coldness of it, it was sucking in the humid air, which was being recondensed and coming back out as sort of like a steam. So it was, but that's, as it turns out, that's not going to have any effect at all. So that was one crisis averted. There was a couple of other little niggly things, and hopefully if they can fix this on the pad, because it's not actually the engine, we understand it's actually in the plumbing to the engine, so they can access it while it's on the pad. It won't have to go back to the VAB, because if it goes back to the VAB, we won't be launching anywhere this week.
No.
And in fact, it could have a knock-on effect to maybe the next window as well.
Well, let's hope that they manage to get it fixed in situ then. Okay, thanks for that, Daz. Now, where should we go next? Let's go over to Keith. Keith, you've got something for us this evening, I think.
Yeah, I'm going to talk about a previous mission to the moon's south pole, because obviously that's where the target is for future Artemis missions. I'll just share my screen, and we'll
take this opportunity while you're doing that to say good evening to Rachel. Good evening, Rachel.
And Steve's joining
Hello,
us.
everyone.
Yeah. And Steve's joining us as well.
Oh, good. He's got in, has he? Good.
Trying to understand what's happened there.
Okay, what's all this about then, Keith?
Okay, back in 2007, NASA launched a mission to the lunar South Pole, and they called it LCROSS, which is an acronym, as you can see in the text there, for Lunar Crater Observation and Sensing Satellite, not to be confused with lacrosse, which is a game invented by North American Indians and played by independent girls' schools in Britain.
It's just a shame we haven't got a video of you playing lacrosse, Keith. That's what I was looking forward to.
Anyway, the plan was to try and detect water ice hidden in the shadow regions of polar craters. It is an interesting fact that even the planet Mercury, which is closest to the sun, has ice hidden in its craters at its poles, because again, they're in deep shadow, and because there's no atmosphere, there's no conduction or convection of heat from sunlit regions to shadow regions. So ice can exist in these places for a long time. Anyway, LCROSS was actually launched along with the Lunar Reconnaissance Orbiter, which most people will know more about, using an Atlas V rocket. Now, actually, this is a clever piece of economic thinking on NASA's part, because they were going to put the LRO on a Delta rocket. And then they thought, well, why don't we stick it on an Atlas and put an extra satellite on board and use the upper stage of the Atlas rocket as an object to crash into the south pole of the moon.
Yeah.
So what they did then is they launched it from the Earth. It then made a pass via the moon. LRO gets dropped off, obviously, in this process. And using the moon as a gravity assist, they swung this Atlas upper stage into a high angle orbit and it's got attached to one end of it the observation satellite or probe, if you like, stuck on one end of the stage. You'll see a picture in a minute. So that's basically it. They launched it in early 2000. I thought it was 2007. I've got 2009 here, but I'll check that later. Anyway, and it crashed into the moon subsequently. All right. So here's a picture, an artist's impression of what actually happened. As it approached the moon, the rocket stage is detached from the probe, and it goes ahead, and then it smacks into the south pole of the moon. That throws up some debris, and the satellite, which is following behind it, then travels through that debris and analyzes what is in the debris field.
Right.
So that's what they did. And in fact, actually, here we've got from the probe an image of the impact of the rocket stage that was moving ahead of it. And in fact, actually, it's virtually impossible to see it in the wide field view. But if you get in a bit closer, you can see a dot. And if you go in closer still, you can see this white region. And so this shepherding spacecraft that was following the stage has got 9 instruments, visible and infrared cameras and spectrometers, and a photometer to measure the intensity of the collision. And the impact plume was detected, although it was a lot fainter than they thought it was going to be. In fact, they were confidently predicting that people on Earth with a telescope of about 10 or 12 inches aperture would be able to see it. But in fact, it turned out not to be the case. But it was detected by the shepherding spacecraft. And subsequently, NASA released the information they had detected water ice and also water vapor caused by the kinetic energy of the impact. So that verified that there is indeed water hiding in the craters at the lunar South Pole, but not as much as they had hoped. And they think actually that L-Cross probably hit a drier spot. And had they hit another place, they probably would have found more ice or had a bigger sort of plume coming up to be detected. Anyway, subsequently, though, the Chandrayaan-1 spacecraft, the Indian spacecraft that was sent to the moon, it actually mapped ice in the lunar polar craters. And you can see these blue patches on the 2 polar maps on the right-hand side. The one on the left is the south pole of the moon, and the one on the right is the north pole. It's hard to see some of the little blue patches, but they are there, hiding in the shadow regions of the craters. So it does look like we're going to find ice down there when the Artemis missions reach that particular place. And basically, that's the story. And these are the proposed landing sites for Artemis missions. And what they propose to do is land in sunlit areas and then basically move into the shadow areas to analyze what's hiding in those shadow areas. So the actual spacecraft will land in sunlight, but the obviously excursions will travel into the shadows to see what's there. And basically that's it. And believe it or not, there's a open source freeware package called Celestia, spelt Celestia, which is banged together by some people in North America many years ago. And it allows you to sort of look at planets and spacecraft and so on. And people make sort of bolt-ons for it. And they actually made one, believe it or not, of the L-Cross mission. You can actually see here the stage separating from the shepherding spacecraft following on behind. And you're looking at the lunar South Pole in this image here. And so the stage is heading for that. And we'll get there in a minute, by the way. It'll speed up a bit when, but basically, there you go. I've speeded it up. It hasn't really gone faster. It's just I changed the framing rate. And you'll see in a second that the, although it doesn't appear to be moving, the shepherding spacecraft is also heading for that South Pole. So having traveled through the plume of debris, of course, the spacecraft has also lost it also collides with the lunar surface. And so, as I say, we're heading towards the South Pole. This is an area of what we call highland region, made mainly out of a rock called an orthosite. It's very greyish white in colour. And obviously, it's heavily cratered because it's a very old surface. And so this is what you would have seen had you been on board that spacecraft. There you go.
It's fantastic. Thank you so much. So I gather you're putting together a series for us on lunar geology, Keith. Is this correct?
Yeah, that's correct. The lunar highlands I refer to there, I'll be talking about those next week.
Okay, so that's something to look forward to next week from Keith, a bit about lunar geology, which I've always found fascinating because a lot of people think the geology of the moon is sort of all the same, but it's not. It's extremely interested in varied geology on the moon. Okay, thanks very much, Keith.
Just to add there, of course, one of the reasons that they've selected as you said, is the old surface. It's very cratered, and the craters are deep enough that the bottom of those craters haven't seen sunlight for millions of years,
if ever.
So if ever, as you said,
yeah.
So it's the ideal place for ice to hide as a frozen entity. So it's and as you said, it's been detected before. So yeah, and this is why. But when you showed the proposed landing sites, as we said on the show earlier, it looks a very rough area.
Yes,
but obviously, when you get closer, you probably find there is some. They wouldn't have chosen areas that are going to be dangerous. I mean, those areas are quite huge areas, and the landing zone is a certain area inside that. But there's a lot of leeway either side. But there's still a lot of data to be collected and imaging, and probably radar stuff to basically find out more and more as they can, as much as they can about these sites before before they choose one.
Absolutely. And we should contrast that with where the Apollo spacecraft landed, which was basically the equatorial regions of the moon, where it was fairly nice and flat. And although, as Neil Armstrong and Buzz Aldrin found out, it turned out to be a bit more bumpy than they anticipated when they tried to land the Apollo 11 lunar module.
A bit more rocky.
Yeah,
but
I'm going to say, you don't want a 1202 on the computer coming up, which is essentially a data overflow, because most people today wouldn't know that there were two computers on board the lunar module for redundancy purposes, and a pair of them each had 32 kilobytes of memory.
Yeah.
Absolutely. So, your mobile phone is a lot more powerful than anything they took to the moon. I've been watching the TV series For All Mankind, and they're in the LEM simulator, and they get a 1202 in the simulator. And I think it shows the respect that the makers of that program had for their audience, that they didn't need to explain what it was. Because a lot of people watching it will, oh God, yeah, I know what a 1202 is.
Yeah, because the 12
information overflow.
as you said, it was a 1202, and the reason they had these alarms keep coming up, but nobody, like you said, hardly anybody knew what they were. So it was designated to one person. I can't think of the chap's name now, where he had to list all of the alarm codes and what they were, and he had less than 24 hours to do it. And it's one of the few times that you will hear, I think it was Capcom, and Capcom's always run by an astronaut, but this chap was in the background and this code kept going off, and of course you hear Neil Armstrong, can I have a go on this 1202 code? And the Capcom actually, instead of going through the usual channels, he blurted out, yes, you can go, because he knew the delay in getting permission to speak would put them in a bit more jeopardy. So they went on it, and we all know the result. It was a glorious day.
Okay, let's move. Sorry, go on.
No, I was just going to say the memory, the 32K memory, was something called ferrite core memory. It's not like a modern solid state stuff.
No.
Consisting of wires and coils. And I was amazed to be told by a colleague that the British Army's artillery was still using ferrite core memory units into the mid-90s. So,
Really?
if it ain't bust, don't fix it, basically. Was the
Yeah,
idea.
of course, yeah.
Exactly. Okay, well, let's move away from the moon now and say hello to Rachel. And Rachel, do we have anything in the viewers gallery this week?
We do, yeah. We have quite a big gallery this week.
Good. So
move
thank you
my
to
hands
everybody
around.
who sent in your images. We do appreciate them, and we do love looking at them, don't we? So so let's have a look at the viewers gallery for this week. What have we got?
We do, and I've got to apologise because those who were on the show earlier might have noticed my hair's slightly darker now, and some idiot decided to do a hair without wearing gloves, and I'm sporting some sort of half-dyed alien hand at the minute. So if you see them, I'm not really unclean. I'm just stupid.
I'm feeling your pain, Rachel. I know.
Let's all club together and buy Rachel a pair of gloves for Christmas.
It comes with gloves. Just I thought I didn't need them.
All right.
I now know otherwise. Swiftly moving on. So this week we've got 2 images from Neil, and there isn't really much to say on this because he's actually put it on his image. So he's got Jupiter here, so I'll just go straight to his image of Jupiter. Obviously, some of it's
That's really good, isn't it?
And apologies from Neil to say you can't make it tonight, unfortunately.
Oh, what a shame.
Yeah.
I'm sure he'll watch us on catch up. So if
Yeah,
you
well,
do,
thank you so much, Neil. That's great.
It does say hello.
Right.
and then Neil also sent in this picture of the moon, a nice photo.
That's lovely. Beautiful.
Watch out, Roger. He's after you.
Yeah.
And
Snapping at your heels, Roger.
Then we've got this nice another image from Bob, and he sent some in before, and Bob thought it's quite a nice thing to ask if you could guess. So he said all 4 rocky worlds in our solar system are visible in this photo. Can you name them? So I've sort of got the photo like this just for you to appreciate it.
That's the moon. I know that one.
And then I sort of zoomed in a little bit to see if anybody wants to have a go.
That's Mars, isn't it? Up there. In fact, isn't there 2 there?
You've got Venus and Mercury as well.
Yeah.
Venus is down below. Yeah,
down below.
So he says we've got bottom up, we've got Mercury, Mars, Moon, Regulus, and Venus.
Oh, well, I'll go back.
And of course the Earth.
And of course the Earth, yes.
I've got to go back to school.
See you later.
Thank you, Bob. Then we've got another image
Thanks for that,
from
Bob.
Lee.
That's great.
And I'm sure Lee is watching tonight because he always watches. So this is his version of the Bubble Nebula. It's more of a wide field one, which I believe is in the constellation Cassiopeia, isn't it?
Yes.
And he said he likes this wider field shot because it includes M52, which is obviously part of the lobster claw section, and NGC 7538.
Wow.
Oh, yeah.
That's beautiful.
And I know he's been really frustrated with this. He's been messaging a lot and he's had about 9 goes and he's finally happy with it. And he's really hard on himself. So I don't know why he is, but it's a lovely picture.
Thanks for that. That's great.
Very good.
Signature too.
Very good.
Then we've got one from Kev, which isn't the sun, and it's the Pelican Nebula, which is obviously near the North America region in Cygnus.
Battling a nearly full moon.
Kev said he was battling a nearly full moon, but he was pleased with the extra 3 hours of data because it's really brought out the detail and the fainter nebulosity compared to his previous effort. But he still thinks it looks more like a pterodactyl than a pelican.
Yeah.
That's lovely. Lovely
That's
colour.
lovely.
Yeah, it's lovely colours.
Yeah.
On that.
Well done, Kev. Well done, Kev. Another winner.
Yeah. And I think maybe this is the last one I want to say. This is the Iris Nebula from Andy Weller. I don't know if he's watching tonight, but he might be. Taken all in one session, and then he's given a whole load of information on the right that I won't read out to you. But obviously, viewers can either rewind or pause if they want to go back and read it all. But it's lots of useful information just about the nebula itself. And obviously, Iris Nebula is a reflection nebula.
Wow.
Ooh.
But you just feel drawn into this. I feel like I'm falling into it.
Yeah.
That's nice.
So this is in Cepheus, isn't it? And the part in the middle is an open cluster, I think. I believe.
Yeah. I mean, the dust there is absolutely striking.
You can feel the texture by looking at it, can't you? And I always say I love pictures that I can smell or feel.
Yeah.
And this one, I really feel like I can sort of feel it.
That would be a great target for the James Webb, wouldn't it?
Those black areas look really black, don't they?
They do?
Yeah, they're really dense.
It's really nice. That's well done.
Thank you so much for that. That's a wonderful.
Yeah.
I've got a question in the chat from Stan Stenkowisk. Sorry about your name, Stan. I can never say it. He's an old pal from SLU days. It says, for Jupiter viewing, does everyone use filters to cut down on the brightness? Who would like to take that?
Roger, do you want to take that?
Well, I usually find it helps me get nice short exposures to get lots of frames per second, which certainly helps to steady the image for when you're stacking it.
So what you mean you don't use filters or?
No.
no.
Only an infrared UV filter that I normally put on.
Oh, okay then. Rachel, have you got anything to add to that, or? I know you're not a planetary.
Really planetary, yeah. So
you're not really planetary, yeah.
I don't really observe. Don't say this. No one will like me. I'm not really an observer. I take pictures and normally. Do you know what? We just decided this week that I think we're going to buy a color planetary image camera, because at the minute we use our guide camera, which is the mono version. So we just said we might tiptoe in. So we're edging there.
Yeah, I mean, if anyone in the chat's got an answer for Stan, pop it in there, and we'll. If Stan doesn't pick it up, we'll read it out as well also. So if anyone's got any advice for Stan.
And Kev's in the chat as well, and I know Kev does some planetary, so he might have some words of wisdom for him.
Great, thank you for the question. Wonderful. Okay, let's move on then. We're going to go over to Lou now, who's going to continue with his series about exoplanets. So what have you got for this week, Lou?
Right. So first of all, thanks to everyone who has hung in there and endured all the sessions of all the methods that we have been covering to detect exoplanets. It's obviously not so simple, and we're going to add another to that list today. And before I do, Keith, I wanted to say to you, I love the animation of L-Cross that you showed. And I might just point our viewers also to we talk about Eyes on Exoplanets that was developed at JPL. Eyes on the Solar System has all of the planetary missions, and I think some heliophysics missions too, that you can go to. You can see what the spacecraft was doing at the time it was doing it, because it has the spice kernels that replicate the spacecraft orientation and position. So Eyes on the Solar System might also be a nice reference.
And I'll post a link to that in the description for tomorrow when tonight's video is processed. So you'll be able to click it in the description.
If you're using that, the flyby of Pluto on that is brilliant. On Eyes on the Solar System.
New Horizons.
Yeah, it's really good. Yeah.
I'll have to fire that up later and have a look. I don't think I've actually looked at the Pluto one. So thank you for that, Keith. I'll have a look later. Okay, so Lou, exoplanets.
Let's go to exoplanets and see if I can start our slideshow here. Okay, there we are. So we have been through quite a labyrinth in discussing how you find these tiny, tiny objects at trillions of miles of distance that have no light of their own. And so you have to be a little bit creative or have great technology. And we've been through a number of techniques. And today we're going to talk about microlensing. So what is microlensing, and how could you use that to detect an extrasolar planet? Well, we are now, thanks to the James Webb Space Telescope, we are now all intensely familiar with gravitational microlensing. And here's the image that we're all familiar with, one of the first 5 images that JWST produced, with the characteristic arcs in here that are the gravitationally lensed and distorted images of very distant galaxies. So we know that mass massive objects, any mass actually, warps space. And that's from predicted from Albert Einstein's thinking about general relativity. So that's for big objects. I always throw this in. This is the NASA Exoplanet Archive with the latest results from the number of confirmed planets and number of candidate planets. And every time I go there, every week or so, it increases by 2 or 3 or so. So we're making good progress there. So gravitational microlensing. So here we have a situation where we are looking at a very distant star, which is our source star. And in between that star and the observer is a planet, is a star with a planet, all right? And as that star and planet pass in front of the source star, we see a brightening because of this microlensing from the star, from the intervening star, and as that planet moves in front of that light path, we also see a slight brightening, and that is an indication that that planet is there. So this is great. This is great for doing gravitational lensing of very low mass objects, but it's not really very good for trying to do multiple observations, multiple detections of a planetary system, because you only get one shot at this kind of thing. Here's an animation of what that looks like. So here you see the planet with the star moving in front of a very distant star, and you see the light curve, the brightness increasing. And then as the planet moves in front of that star, that also has a microlensing effect, and you see a slight bump in the light curve, and that is evidence of an exoplanet. Here's some actual data. I forget which star this is. Ogle 2005 BLG 390. Okay, remember that. And so here you see the same kind of qualitative curve. It rises as the exoplanet star moves in front of the distant star, because you have microlensing that's brightening the image. And as the star moves away and the brightness starts to wane, you see a slight bump on the right-hand side there, and that is a exoplanet. Well, as I mentioned, this is great for some things, but not so great if you want to do follow-on observations, and you have to have just the right alignment of the exoplanetary system in front of the distant star. So here we see the number, cumulative graphic of the number of exoplanets detected. And in purple, this third item down here is microlensing. And you can see the little purple streak on top of each of these curves. So not many exoplanets have been detected so far from this kind of technique. And in fact, the very first exoplanet detected with a microlensing technique was in 2003, which was Ogle 2003 BLG 235 MOA, just a catalog number, but in 2003, so fairly recently. And here they are. Here are all of the exoplanets that have been detected by microlensing. There are only 37 of them out of the more than 5,000 planets that have been detected. But this is a really great technique for detecting low mass planets, right? So that are far away from their star, right? So you have separation between the light curve of the star and the light curve of the planet. That's very different than what we had been talking about before, where you want very massive planets for, say, a transit detection very close to the star. So this fills in a gap of exoplanet detection. This is kind of a cool little, as my last slide, this is a cool little animation of the exoplanets that have been discovered over time. And of course, the time is very, very much sped up here using the micro lensing. Here, let me play that one more time. Using the micro lensing technique. So just kind of where they are and in the sky, and kind of a sped up chronology of detection of exoplanets using micro lensing. And
Brilliant.
I will stop there.
Thank you very much, Lou. That's fascinating. But as you say, the alignment there is crucial, isn't it? It's you know, if you want to see another event from the same planet, you've got to wait till it passes another star, and obviously, as you said, that's not going to happen very often.
Right. So you would use it as an initial detection, and then say, I think I found something, and then you'd go rely on some other detection methods that could maybe confirm these candidate planets.
Great. Well, Lou, I have to say your series on exoplanet detection has been absolutely fascinating. Thank you so much for doing that. Is there any more to follow, or was that the last one?
That is the last one of the series. If we have time next week, I might go into a little more depth on the eyes on exoplanets and the NASA Planetary Exoplanet Archive.
Right.
Thank you.
Because I was wondering whether, in fact, it might, whether you'd be interested in putting together some statistics for us about, for example, the types of planets that have been found.
Absolutely. And you can find this very easily, so I'll do that next week.
Because I think that might be kind of nice to just finish the whole thing off. What exactly are we looking at? What are we discovering, in terms of planets?
Exoplanet Archive will help us with that.
Thank you very much.
Thank you. A question or thought?
Sorry, no, I was just got a question in the, it's an answer to...
It was pointing at the sky.
Yeah, it's up there. In answer to Stan's question as regards filters and Jupiter, Kevin Earp put Stan, as Roger says, for imaging, it's best not to use filters as it reduces frames per second. For visual, red or blue, I believe, can be useful to enhance contrast. And then Stan replied, Kevin and Roger appreciates the experience. For moonshots, I find adding filters helps cut down the brightness. Even so, I can try to capture more detail. I was wondering if planets were the same. Thank you. And then as a final shot, Roger's put some planets benefit different filters. A UV filter is good for getting detail on the atmosphere of Venus. So
yes, we've forgotten about Venus. Yes.
And then also it says some people use green filters to enhance contrast on the moon. So there's a little bit of a chat going on there now. So if anybody,
okay. Thanks for your interest, guys.
Mars too.
Well, yes.
Colored filters to bring out the polar caps, atmospheric features, or surface features.
Yeah. Right. Thank you all for your contributions to that discussion. Very kind of you. We have to say good evening at this point to Steve, who's finally managed to overcome the technology.
Hi, Steve.
Hi, Steve. How are you doing?
I'm all right, thanks. Good evening, everyone. Can you just quickly go through everything again?
No.
What did I miss? What did I miss?
You have to get it on catch up, Steve.
Yeah,
absolutely.
I was so frantic to get in that I've gone through my entire supply of sherry in the meantime.
Oh dear, no.
The stress.
Yeah, absolutely.
Rehab, here we come.
Do you have anything for us this week, Steve?
Only if you've got considerable space. I've not lined anything up, but if you've got plenty to go on with, carry on. But otherwise, I'll try and think of something if you are in.
Okay, fantastic. Michael, what's going on at Go Space Watch?
Okay, well, unfortunately, not a lot at the moment. I've just had to change the date of one of the lectures coming up. But I'll just find my page. So the next one planned that we've got, although I say planned, before that though, we did have a watch party for Artemis this morning, which as you all know the outcome of that one. We are planning to do another watch party on Friday if they get the go ahead to launch on Friday. But after that, I'm not sure. But our next one, our next Go Space Watch lecture will be on Thursday, the 6th of October, which is from Astro. The title is Astroscale: Bringing Sustainability to Space, by Andrea Stewart from Astroscale. And after that, we have the 20th of October, Sky Aurora launching to space from Shetland by Derek Harris of Sky Aurora. So that's
fantastic.
what's coming up at the moment.
Things are moving on with Sky Aurora a bit now, aren't they?
Yeah, that's right. Yeah. So that's why I thought it was a good idea to get somebody in to talk about what they're doing.
And where can people find details of your talks if they want to?
Yeah, if you go to the website at gospacewatch.earth, the details of the talks can be found on the front page of that website.
Right. And next week, I'm going to be giving you a full report on Astronomy Island Starbecue that I was there for at the weekend. All the photos and videos are still on my camera. And I've been sleeping pretty much since I got back. So I'll sort those out over the coming days and tell you all about it. And as I said, if there is anybody watching from Astronomy Island, thank you so much for your hospitality and friendship. And it was lovely to meet so many great people while I was there. Had an absolutely marvelous time, and it all went so quickly, unfortunately. But it was great. It was a wonderful event. Okay, then. Well, if there's nothing else from anybody, I think we'll call it a night for now. And we will see you this time, 8 o'clock UK time next week for another edition of Space Oddities. Thank you so much for being here. Don't forget to like and subscribe if you would be so kind. Your subscriptions, which are, of course, entirely free, are very valuable to us to help us get noticed by the YouTube algorithm. Also, liking the show is important.
Yeah, same with notification as well, please.
And the notification bell, absolutely. So, does anybody on the panel want to say anything before we close for the evening?
Well, we were all expecting to be talking about SLS this week. Yeah. But the only other thing that's been very active last week was the sun. Yes, there's been some huge activity on the sun facing us, which has created some problems for radio, amateur radios, and the emergency services. But also, it's given us some lovely auroras. Keep watching the sun, and it's still firing up. We've still got a few years before it reaches its max. That's basically it.
Steve wants to...
Oh, hello, Steve.
Well, I was just going to apologise to everyone, both on the panel and elsewhere, for the glitch. It was a Zoom update, I think, that seemed to mess up my system. I couldn't get anything to work. Had to completely reboot. And I would have had available a little presentation just about kind of astrophoto fakery, which I'll do that another time. But the other thing I can throw into the ring is that our good friend Pete Williamson has an astronomy day coming up this Saturday on, you may have already mentioned this, forgive me if so, 3rd of September at Whittington Castle in Shropshire. SY11 4DF, I think is the postcode.
Okay.
That's in my head now. And there's three talks going on, one of which in the middle is mine. There's one on constellations and asterisms and lost constellations. That sounds very interesting. And also one on chasing aurora by Tracy Snellis, as was Hearty as is now.
Because I hope to be there.
Good.
I think Keith said he's hoping to get there.
I hope to be there as well, but
that's brilliant.
Depends on my circumstances on the day.
So hopefully we'll be there. I think maybe even Kath might be there, and there may be some freebies being given away. So.
Yeah, well, we can have a group hug at last.
Yeah.
Oh, yeah.
Social distance.
All right, not without me.
Yeah.
Can't do it without me.
Yes, because I've never met any of you.
That's probably a wise move, Michael.
Let's put it this way: if there's a group hug, you'll need long arms to get around me. My partner says if I gain more mass, I'll end up capturing my own moon.
If you gain more mass, Daz, light will be bending around you.
Exactly. I'll be micro lensing.
You'll be micro lensing.
I think on that note.
Yeah, on that note. Steve, where can our viewers find details about the Whittington event? Do you know? Is there a web page?
There is a page on the. There is a page on Facebook for it, isn't there? Yeah.
And what do you know the name of the page?
No, I'm not. I can find it.
I've seen a poster, Whittington Castle Astronomy.
Whittington, that's Whittington, Whittington, Whittington Castle. If you search for Whittington Castle, you're almost certain.
It's a lovely venue as well.
I think it's a free drop-in event for enthusiasts and for public, and I think there's just a small charge for the 3 talks, but I gather it's only small.
Fantastic.
I'll be there to heckle.
Well, I hope it all goes well. I hope the weather stays good and the clouds stay clear. Skies stay clear. That's what I'm trying to say.
The flies.
Sorry, I've lost the power of speech.
Solar observing as well, actually. If it's
good.
So let's hope for good weather.
Oh, fantastic.
And it looks as though it's clear tonight here as well.
Sorry?
It looks as though it's clear tonight here.
Oh, good. We've got cloud and looks like rain coming in tonight. But it has been 38 degrees today, so I've got a nice cool breeze coming through the window now.
Oh, big coat weather.
And I'm going to bed because I started at 4 to get back from Ireland this morning. So I think I'm going to go to bed. And there we are. All right, then. Thanks so much for being here, viewers.
Thank you, everyone.
As I said, anybody new, especially from Astronomy Ireland, lovely to see you. Hope you'll be back here next week. Don't forget to like, subscribe, and notify. And we will see you next time on Space Oddities. Yes. So from all of us on the panel,
bye for everyone.
It's goodbye for me, and it's goodbye from them. Bye-bye.
Thank you. Bye.
Okay, that's a wrap.